Hello and welcome to another exciting episode of All About AI with Ali Abidi. I am your host Ali Abdi, and today we have a very special guest who is going to join us today from the forefront of some most fascinating areas in technology. David Knickerbocker is a legendary expert in network science, machine learning, and has a deep understanding of both these fields and how they intersect with each other. His work focuses on pioneering advancements in graph machine learning AI, pushing the boundaries of network science, design thinking, and a lot of more insights that he's done as a senior data operations manager in cybersecurity in OSINT while working at top companies in the field of cybersecurity and data science. So today we'll have a very exciting discussion with David and moving y'all to the feature, which is our conversation with David Knickerbocker. Thanks. So, welcome to the show, David. Great to have you on All About AI with Ali Abdi, and is a pleasure hosting you. You are the legendary David Knickerbocker, and I'm really excited to have this conversation with you.
Thank you. I'm really happy to be here, and I know we've been talking about this for a few weeks, so it's really cool that this is the moment.
Absolutely, David. It's always been a pleasure talking to you, and you taking out time, especially for the viewers and for the show, makes a lot of difference. So let's start without wasting a lot of your time. So, David, I know maybe a lot of people might not know this that you have, been living in Japan, growing in your years in Japan as an American. So, how has that cultural difference? Growing up in Japan and working there or living there shaped your perspective as a writer or a scientist?
Thank you. That's a really good question, and it's something that I very often think about. One of my first memories in life is the day that I flew to Okinawa, Japan, when I was 5 or 6 years old, and I remember being in a car, a taxi, on our way to our hotel where we were going to stay our very first night. And even though I couldn't read as a kid, I had gotten comfortable with English language letters from living in the United States. And age 5 or 6, it's a long time ago, 1986. Um, I remember just seeing different characters on the sides of every building. And even though I couldn't read anything, um, it was a very unusual thing for me. It was like being thrown into a completely unknown situation at the very beginning. And so that really definitely had a profound impact on my life because I had this feeling of kind of being an outsider, from not being here. But it sparked my curiosity so much. Like, what is this language? What are these words? And it's so much more complexity than just growing up in one place with one language, with one um, cultural group and things like that. So growing up in a different culture had such an impact on me that I could fill up 10 podcasts, 10 books, just talking about the whole thing. But I will say that it had a lot of challenges. It was good and bad, but it was mostly good. And I am who I am today because I lived through that. And I would say overall, the impact that it had on me that's relevant to kind of this AI network science stuff that we talk about is it kind of turned me into an observer. And that's the way that I think about myself very often. And so I like to pay attention to the world. I like to see what's going on. I like to understand things, not just hear things, but understand things. Like ask the why behind the why, and then ask the why behind that why. Take it even further and further. And so there's a lot going into language and influence and psychology and human behavior into all of my work. And so just growing up outside the United States, it just had this profound effect on me, and it made me a very curious person. And and I was born with a very active imagination, and so I've always been just, why is this happening? Why is that happening? Always asking the annoying questions. I was just that kid, and you can imagine me growing up in that situation. I had tons and tons and tons of questions, and so it kind of pushed me towards science. Um, and people don't always agree. Like people don't always agree with each other, period.
Mm.
And so when you
Right.
live in a place with cultural diversity like that, you see different perspectives. You don't only see one perspective. And so that definitely had an impact on me as well. So probably the overall impact on it just it blew my imagination up, and it made me a really curious person, and it made me just want to chase insights and just needing to understand things. And so that drove me towards science and engineering. So
That's a great experience, David. I think multicultural shows in your personality as well. When we talk to you in your writing as well, you have a very broad perspective of things. You look at things from various angles, from various perspectives, and that has really enriched your personality. So I think it was a good thing for all of us that you lived in multiple countries, learned Japanese, etc. I think that's a great positive in terms of your authoring. Also, I think it shows it in a way where you tell stories which resonate to a lot of more people compared to somebody who is not multicultural. So I think
mhm.
that is a major advantage. So moving on, you describe yourself as part scientist, part engineer, and part mad scientist. So do you think, how does these different aspects of your personality influence your work and the way you reflect in your books? Does it have a profound impact, or how do the readers get each flavor of these personalities that you have?
Yeah, that's a good question too. Kind of the way that I think of it is the science really gets to the why. It really
Hmm.
gets to the why is this thing happening? What's the cause and the effect? And for me, I always this comes from me working in data operations. Like whenever we'd have data problems, we'd have to do root cause analysis. We'd have a manager very angry that a server was broken, and the whole team would have to go figure out what's the root cause analysis. And so as an engineer, when you're doing
Hmm.
root cause analysis, you are kind of thinking as a scientist a bit more, and because you have to find the cause in order to stop the bad thing from happening. And so engineering is or science is kind of the why,
Hmm.
and there's always going to be that. But I'm not only into science. I like to build things that actually have impact on the world. And so that's the how. Engineering is the how. And so engineering is the how, and science is the why. That's kind of the way that I see it. But I'm a very curious and creative person. And so I've been called a mad scientist by friends in the past, and that's kind of where it comes from. And it kind of sticks. But I have a couple of quotes that I brought to this podcast.
Hmm.
I don't really think of myself as a mad scientist as much as I think of myself as just imaginative, or
Hmm.
curious, infinitely curious. And so I have a quote from Ada Lovelace, and she says, "Imagination is the discovering faculty, preeminently. It is that which penetrates into the unseen worlds around us, the worlds of science." And so what Ada Lovelace is saying, science exists because of imagination.
Right.
It's somebody sitting in a quiet room thinking about something deeper than somebody else was thinking previously. And it's that imagination that leads to experimentation. And those experiments lead to the why. It's not starting with math, it's starting with curiosity, imagination. So the second quote I had comes from Albert Einstein, and that is, "Imagination is more important than knowledge." That's a
Hmm.
really solid sentence, or a really strong
Absolutely.
opinion. Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. And I really like that, because the the subtitle of my book says "Explore the networks around us using network science, social network analysis, and machine learning." And that word "explore" is really the mad science part that I'm getting at, the imagination part. And so, kind of, whenever I show people how to do things, I'm trying to push the boundaries of what's possible. And when I see people get stuck on one thing, I like to say, "Hey guys, there's this other thing over here too that's also important. Let's keep all of them in check, and let's keep expanding,
Right.
our whole knowledge base, not just one partial part of the
One
knowledge
part of
base."
it. Yeah.
So that's where the engineer science and mad scientist part comes from. But the mad science part, it's my favorite part of me. It's my infinitely curious part. Like on the weekend, I like playing with data. I could just be resting, but I like to be playing with data, and I like to be playing with networks. So
Right. I think really great pro that you got from Albert Einstein, especially very strong opinion about imagination and intelligence. I think to a very large extent it's true because I think people are most curious when they are children, and children have a very high sense of imagination,
mm,
and they often question a lot about the why something is the way it is. But sometimes, as we grow up and we get burdened with responsibilities, we don't really care about imagination a lot. But in your case, I think you've been imaginative as much as you've been in your childhood days, because you question a lot of things, why this works the way it does. And I think that is, you could say, a major part of your personality, which could make people think that you are a mad scientist or something of that sort. So I think that is the
yeah,
reason I think your friends would want to say that to you. But I think it's a good thing to be called
me
as a
too.
mad scientist. Scientists who are mad are the most successful ones, I think, in my view. So yeah, I mean,
Me too.
moving on to
It's fun to be creative.
absolutely, absolutely. I think without creativity and imagination, life is really boring and dull.
That's right.
But it makes sense to be creative all the time and try to do things differently. All right. So, David, moving on to the next question. So, you are very passionate about network science, and you and I have collaborated on your first book,
Mhm.
which I have with me today, Network Science with Python. Guys, do check this out. It's one of the best sellers in the stream, and it's still holding its ground. It's getting old now. We are working on a second edition, but it's still very relevant and very important book. So, David, what inspired you to write this book? I know this partly, but for the viewers who are watching and listening, what your motivation behind writing this book? What was the need that you thought that okay, this book is required in the market here?
Yeah, the reason why I wrote this book is because I had discovered that, I mean, I'm not the first person to discover this, but like I had my own self discovery of just the importance and usefulness of learning how to analyze graphs. And I did a podcast recently where we talked about using graphs for data operations. And so that's where I kind of discuss what I'm about to say more. But it goes back. It goes back to forever for me. Like I was always enjoying connecting the dots when I was a kid, and I was always enjoying looking at space and seeing the stars in the skies and drawing my imaginary lines between them,
Hmm.
as people have always done. But when I worked, I've always been working with computers. I've been programming since I was 6 years old. I was doing databases
Right.
when I was 16. Um, and so that means that I was learning about relational databases when I was 16 years old. And with relational databases, the tables are they're connected to each other by a foreign and primary key. And so in a relational database design, all of the tables are a network. And there's typically, a few um, very important tables in that database that are linked to by all the other tables. So I started noticing kind of these network shapes as a database administrator a long, long time ago. And I would see these shapes with how the tables are connected. I've created so many entity relationship diagrams. I could write a whole book on just that kind of stuff. If we were 20 years ago, people don't talk about relational
Yeah.
databases as much anymore.
Yeah.
But it's still very important to know how to do an entity relationship diagram, for instance. And an entity relationship diagram shows the network of a database. It shows the graph of a database. So databases were the first place that I saw it, but then I had a job working in data operations for 7 years. And that was more than just databases. That was all servers. That was a whole data center that we managed. And so what was important to me then wasn't just one database. What was important to me then was data flows across an entire data center.
Hmm.
So we're talking about hundreds of servers and how they communicate with each other. And I did this at McAfee and Intel, where I would map out
Hmm.
data flows across hundreds of servers, and nobody was doing this.
Yeah.
And um, what I found was that when I started doing this with even one server, mapping out how one server would work, we were able to uplift servers in 1/10 the amount of time as it previously took. So that's a 90% cut in the amount of time. That's a huge savings when you think about manpower,
Right.
when you think about all of that stuff. So I saw usefulness in databases. I saw usefulness in data flows. Then I got pulled onto McAfee's AI research team, and I did some malware analysis using networks. And I
Mm-hmm.
found that I could fill gaps of unknowns by looking at common behavior of
Mm-hmm.
unknown malware, for instance, using graph. And so everywhere I looked, I was seeing different uses for graphs, and that's what kind of led me to this network science stuff. But I'd never heard of network science until I took one class from Coursera, and like I said, I've been connecting dots in the sky since I was a kid, but somebody came up with network science. Albert Baravasi came up with network science not that long ago,
Right.
and it took on a name. Just like natural language processing has a name today, or artificial intelligence
Nowadays.
has a name today, or information theory has a name today, network science has a name for quite a while now. And so I got really intrigued by that because I don't like computer networking. This is an interesting thing about me. Like if there's one part of IT that I can't stand, it's networking. And that's the weirdest part about me because I wrote a book on network science and I love networks in general and I love graphs, but I hate TCP/IP networks. I love analyzing them, but I don't like all of the rest of the work that has to do
Those
with
are your
network.
pet peeves.
Yeah, yeah. So, but I took a class from Coursera, or I took a series on data science in Coursera because I've been programming since I was 6 years old, but I very quickly wanted to get up to speed on Python.
Right.
And so I enrolled in a class that should have taken 3 months, and I enjoyed it so much that I just spent a year and a half in it. I took it as slow as possible. I didn't mind spending as much time as I wanted on it because I just wanted to take as much out of it as I could. And this is where I built a lot of my skill. Was I didn't rush through the training. I spent way much longer, a lot more time on it than I probably should have. But I enjoyed it just so much. It was like my little weekend vacation thing,
Mm.
sandbox kind of thing.
Yeah.
But it was a 5-course specialization through the University of Michigan. Um, and the last course was called Social Network Analysis with Python.
Mm-hmm.
And I thought, I don't want to analyze LinkedIn. That sounds boring. I don't want to analyze Twitter. That doesn't sound fun. Um, but what it meant by social networks was the social networks of people. So like right now, you and I are a social network of 2 people having this conversation. And if a
Right.
third person were to join this conversation, then it would be a triangle. This would be a very
Triangle. Yeah.
simple social network. Whereas, my LinkedIn network is 35,000 connections. And those 35,000 connections also have their own connections too.
Connection.
And so it's not a star graph, it's this very complex ecosystem that exists in data science. And I show that kind of stuff in my
Mm.
book and in my blog. So my first impression was that 5th class was something that I would just skip because I thought, I don't want to learn how to analyze LinkedIn. That sounds dumb, you know. But when I learned it was actually about analyzing social networks, not just social network platforms, but social networks themselves, then I started thinking about I can use this on literature. And so
Mm.
I actually used it to analyze the social network of the book of Genesis, the Bible, from like 6,000 years ago or whenever that was written. And that was my very first experiment. And like, there's no coming back after doing something like that. You took a 6,000-year-old piece of text and were able to wire it up into a social network that you could analyze. It took my breath away. And then I
Right.
started thinking about what I could do with malware and what I could do with all kinds of bad things, like stopping bad things and helping good things.
Good things.
You can use networks to block bad. You can use networks to promote good. So
Right.
everything behaves in a network. And yeah, it was a very important moment for me when I took that class, and I just loved it so much. And eventually that led me to, Pact has been, I think Pact has been emailing me since about 2017, asking me if I wanted to write books about machine learning and stuff like that. And I didn't want to write a book on machine learning because, there's 100 other books on machine learning. Like I said before, I like to fill in gaps
Right.
that where knowledge isn't really being met. I like to fill in that gap. If there's 100 people talking about this thing and there's 0 people talking about this one thing, I just instinctively go over there. It's like,
Towards
look at
that.
this. This is also very important, you know. And it all really is important, because if you want to work with, RAG, if you want to work with graph databases, if you want to work with anything graph related, you should be capable of doing the bare minimum with a graph.
Hmm.
So you can think about my book as kind of the hello world of graph, you know. Um, and I wrote my book because during my time at McAfee, there would be a lot of um, innovation teams where they would do something with the graph database, and it would never go anywhere because the fundamental knowledge wasn't there. Or I worked on a team where we built with a graph neural network, and it never went anywhere because the foundational knowledge wasn't there either. And so kind of my book, it came from years of frustration, if I'm being honest, because I kept seeing people want to do stuff with graph, but
Hmm.
but they constantly, to this day, skipped past the fundamentals. Like, you can't skip the fundamentals. If you can't do hello world, why are you playing with AI?
Right.
You know, so that's
That's a
kind
very
of,
solid motivation. Yeah.
yeah, that's kind of what led to the book. And I didn't want to write just a little tutorial. I wanted to write a beefy book. I
Hmm.
wanted to write a book like top down, um, because I wanted to show people how to get past some of the problems that I saw at McAfee, like, and other companies. For instance, some of the problems that people would often face is they would get stuck on whole network analysis. Like, okay, now you've got a network, you've got a graph of 30 million nodes. What are you going to do with it? It really depends if it's a social network, or if it's a RAG, or if it's something else, how you want to do something with it. But if it's a social network, a people network, or a computer network, and it's millions, you can use community detection, for instance, to split this massive graph into a ton of tiny graphs that you can analyze instead. And so that's why there's a whole chapter in my book about community detection, because that helps
Hmm.
people get past the problems that I saw previously. You know, so my motivations for writing this book were to push AI, push data science, push software engineering, and push the social sciences further. I wanted social scientists to learn engineering skills so that they wouldn't have to work with these teeny tiny little networks, that
Hmm.
are often used in papers that I read. And I wanted engineers who have no trouble thinking big. I wanted them to learn from the social sciences as well, because there are computational social sciences. There are all these different fields other than data science, other than software engineering. There's computational linguistics, there's computational humanities. Like, for a creative person, the world is rich with what you can learn from, and getting back to creativity and imagination. It's like
Imagination. Yeah.
come full circle. That's kind of my story for why I wrote the book. I know it's kind of all over the place, but that's why.
No, I think it's very comprehensive, David. I think that's a very strong motivation. The challenges maybe you faced when you were picking up the field. You didn't want others to face that challenge. You wanted to grow their fundamental knowledge so that they would be in a better place when they are picking it up. So I think that's a very solid motivation. It comes from a point where you want to give back to the community so that they don't really face those problems that you face, say, at your professional life at McAfee or any other companies where you were, solving this problem. And now that you have a best solution for it, you thought of sharing it with the other community members. So that's a very good thing to do. Uh,
That's right.
yeah,
Yep, that's right. I used this for years before I wrote my book. So by the
right.
time I wrote my book, I could do this in my sleep. It was easy.
Right, right, absolutely. So while we are at the topic of writing the book, I wanted to understand because there are a lot of people who watch this podcast and they aspire to be authors someday. Can you give us some behind the scenes stories or challenges that you face writing a book? Because I know you had a full time job, you were starting up your own company. It
Hmm.
was a very busy period in your life when you started writing the book, but it all kind of fell into place. But what were the challenges that you faced as an author?
Yeah, it was a really interesting adventure, and in hindsight, I have no regrets whatsoever because we did it. We did both. I did both. It's really about understanding. It's really about understanding what your capabilities are, what your limitations are, and knowing your energy levels. But writing a book to me is as simple as writing an article is to me. It's just you show up and you keep doing it until it's done. But to me, the art of creation, it always starts with ideation. It always starts with an idea. And so
Hmm.
the first thing that I needed to do was figure out what my idea was for my book. And
Right.
that didn't happen immediately. Like the original title of my book, and I've got my book in front of me too. The original title of my book was going to be Network Thinking. Um,
Thinking, yeah.
and and it's because I saw two blog posts at the time that I really loved, and I hadn't, I had heard of, I think I had heard of the term systems thinking before,
Hmm.
but I had kind of forgotten about it for a while. But then I had read about network thinking, and it reminded me. And also during my time at McAfee, I heard a quote that, McAfee is an antivirus company, a cybersecurity company, and so we
Right.
defend. And the quote was that defenders think in lists and attackers think in graphs. And what that means is that defenders have a list of things that they have to defend. They
Thank you.
have a list of their
Checklist.
infrastructure that they have to defend. But attackers have been busy probing all of your infrastructure, and they've been mapping out your infrastructure. So they have a graph. They understand, just like the scene in Star
Hmm.
Wars, that when you hit that key node in the Death Star, the whole thing blows up. So, um, yeah, I kind of lost my train of thought there. But attackers think in graphs, defenders think in lists. And I'm
Right.
sorry, man, I totally
No
blanked out. Can
worries.
you
No worries.
remind me where we were for a minute?
So basically, we're trying to get to the challenges that you face while writing the book. So you
That's
were
right.
balancing and juggling a lot of things, but
That's
still you managed to pull it off. Yeah.
Yeah, thank you for reminding me. My brain sometimes just throws
No
all
worries.
I was holding in the trash.
It's a lazy
Um,
Sunday.
so the first
Yeah.
thing is you have to come up with a good idea, and so like
Hmm.
that takes time. Spend all the time that you can just sitting outside. Like I like to sit outside looking at squirrels or listening to the birds.
Right.
Wherever you have peace, find your peaceful, quiet place, not in front of a computer, unless that's actually what gives you peace and quiet. But find your one thing that you want to write about. And eventually, I landed on network science because I found network science had usefulness in social network analysis, and it had
Hmm.
usefulness in the data stuff that I was talking about as well. And so network science is what I landed on because it was kind of the thing that tied everything together. So once you have your one thing that you want to write about, if you're writing an article or if you're writing a paper for college, or if you're a newspaper writer like I used to be at the very beginning of my career, you pick your 3 points. Like any kind of persuasive essay, any kind of point that you're trying to make, you come up with your 3 points
Hmm.
to prove your side of the equation. Um, a book is like that. Every chapter that I write has 3 points or 4 points, like roughly around that many points.
Hmm.
But the first thing that you do is you come up with a good idea, and then you come up with what you think the outline for your book should be. And so when I come up with an outline for my book, I'm teaching this to people who have no idea how to do this. And so part one is going to be introductions and prerequisites, and part two is going to be getting data and cleaning it up and making it useful. And then part three is going to be doing all the fun stuff, like getting
Hmm.
into community detection, egocentric network analysis. Like you have to have actually clean data in order to
Exactly.
do the really exciting stuff that you want to do. And so I wrote my book as foundations, clean it up. Now let's go have fun together, you know?
Hmm.
And, but again, that gets back to the 3 part idea, of writing. Like my book is a 3 point essay, foundations, clean it up, let's have fun. And each one of the chapters in my book is like that too. So chapter one is, what is natural language processing? And so, or I think it's been a while since I read my book. But in the natural language processing part, I go over what's the history of it and what are the use cases for it and blah, 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 blah.
Introduction. Yeah.
So if you think about what I just said, the art of creation also follows a network because you start at one node. That one node is your idea, right? And so from that one spec, you have your one idea, your book idea. And from your one dot, I've branched out to 12 chapters. And from those 12 chapters, they have 3 points to them as well. And so this is already turning into a graph,
Yeah.
that you can think about if you could think about it that way. So, and the rest of it, if you have a good plan, it's just showing up to do the work. And so, I used Google Sheets to set myself up with a tracker. And so my tracker would be like chapter 1, chapter 2, chapter 3, all the way to the end. And it would be, and column A would be like written, and column B would be images are in place, and column C would be edited, and next would be second round of editing or whatever. I don't remember
Mm-hmm.
exactly everything that we did, but the tracking spreadsheet turned it into just this thing that I had to go through. And so chapter 1 had 4 things, chapter 2 had 4 things. And by the time I got to the end of the book, everything was just green, top to bottom. We did green check marks, top to bottom. And that's the day that we were like, okay, book's done. We're done. you know? So writing a book can be really mechanical. This isn't writing literature or poetry. This was a really technical book where I had
Technical book, yeah.
something with intent to write. You know, so
I think great experience that you've shared. You shared some really good tips for aspirational writers about the 3 point chapters and having 3 points in all of their writings. I think it makes sense. It communicates better with the audience as well. It helps them grasp, especially the example that you gave, wherein you start with foundational, then you move to cleanup, and then you get the hands dirty. Is a very good approach, I think. That really instills confidence in the readers when they start off with something new and something as complex as network science. So I think that's a great approach, David.
thank you.
So one another question which I have around this is, so your job or the work that you've done in your career is very serious. Like, you've been doing cybersecurity, you've been running research for McAfee and all these companies who are doing difficult things, trying to protect very important data, and you are working with OSINT. So how do you balance this seriousness with, the light-hearted examples, the playful examples that you have in your life, and a very playful personality that you have? So how do you balance this out? That does one overpower the other, or do you think it is important to have a mix of both?
Yeah, it really depends on my mood. Like sometimes I want to hunt bad guys, and sometimes I don't want to think about them. So sometimes you want to play with the malware, and sometimes you don't want to. You want to go analyze something else. So it really just depends on my mood and attitude at the time. You know, but when I wrote my book, I didn't want to write a scary book, and I didn't want to write a cybersecurity feeling book. I wanted to write a book that would be attractive to social scientists. I didn't want to write a book that would just be attracted to a certain demographic. I wanted it to be broad, you know, and everybody knows the story of Alice in Wonderland, I think,
Right.
or a lot of people know the story of Alice in Wonderland. And um, actually, people got excited about what I did with Alice in Wonderland at McAfee. I actually
Hmm.
gave a talk about, before I wrote my book, I gave a talk at one of our innovation summits on using graphs and network science for data flow. And as part of my talk, or no, not part of my talk, after my talk, a few people got really excited about what I had shown. And so they asked for a follow up meeting. And so I showed that, I talked to them and I said, yeah, you can take the text of Alice in Wonderland or any text in the world and use it to create these social networks using named entity recognition. And they're like, oh, wow, no way. And so I showed them Alice in Wonderland, and it really, really impressed them. Like, it just, really serious people have a very curious side and a very creative side too. We're not just serious all the time, we're playful. And we all like Alice in Wonderland. It's a really cool story. It's a really trippy story. It's a really surreal story. It's really cool. It's one of my favorites.
Right.
Um, so I use Alice in Wonderland in the book because it's non-threatening. I'd rather play with those kinds of networks in my book than what I look at in my job, for instance, when I'm teaching something.
Hmm.
Um, so that's why I did it. But I wanted to show that any text can be used this way in my book. And so in my book, I use Alice in Wonderland, but I don't only use Alice in Wonderland. I use a few other books, as well as news articles, to show that it's possible. So
Yeah.
text is data. That's the thing that people should start thinking to say, is that text is data. And I have a book on my bookshelf called Text as Data. And
Hmm.
I think Pact had a really good book this year. Hold on, I'm gonna get it. These two. I'm sorry. But this is a very important book. Text as data. This is not
Data.
a
Yeah.
small. This is a very solid book for anybody who's doing natural language processing to learn. And then Pact came out with a very similar book this year. Um,
Yeah.
this one, and I love this book, and I'm really happy that people are writing this kind of book because language is data. The words that we say
Hmm.
are used to persuade each other. Like we program each other. We pass information. We hope that it sways another person. Like information, text, language. Um, these are the words. These are the things that we use in order to influence other people. And text is data. Text is data that can be analyzed.
Right.
So, but yeah, I like to keep my book really lighthearted and just have fun with it, and but also show some fun simulations. Like I think I showed one simulation in the book, or at least on my blog. Like, what would happen if the Red Queen actually won? What would happen if the Red Queen actually did manage to kill Alice like she wanted to?
Hmm.
And I think I showed it in my book, but I for sure show it on my blog. But the whole social network of the book just disintegrates. So I mean, it just breaks apart into all of these different pockets of characters that were together. So, like, if you take Alice out of the equation, then the Tea Party, the Mad Hatter and his little Tea Party, they're just this island over there, and the Red Queen is her own thing over there. Because the central node has been taken out.
Taken
It's no
out. Yeah.
longer connecting these two communities. So, yeah, it's a serious book, but it's also written in a non-serious way because I want to keep it lighthearted and I want people to have fun. And also just because not everything is serious, like computational humanities is a field I would love to see grow, and the social sciences are fields that I'd love to see grow. I really hate the notion that STEM is everything and STEAM is not. I find engineering to be cold by itself. I like engineering and
Hmm.
art together. I love the
Together.
computational humanities. And so there's a big part of my desire to want to do computational humanities in this book. When I get old and decide to stop chasing bad things, this is what I'm going to do. You know,
I think that's a good plan. I mean, that you have for yourself. Uh, that brings me to the question you mentioned, David, about your blog. You like to share knowledge, you like to share it with community members who can pick it up from your experience. So, you have a series of blogs that you call 100 Days of Networks, and that has gained a lot of popularity, especially amongst the NLP communities.
Mhm.
So, what is your approach in creating content for the blog since you're also writing a book? So, does it complement the book, and how do you manage to, churn out so much content for the community while keeping your busy schedule at check?
Yeah, the book is, I mean, the blog is kind of my way of keeping the book alive.
Right.
Is the real spirit of the blog, um, in two ways. One is that a book is kind of an anchor in time, and so my book came out February 2020, 2023, I think. So almost 2 years ago, and it blows my mind that 2 years has gone by.
So
But
fast, yeah.
but that makes me nervous because like some of the code doesn't work anymore, or some of the code needs to be revised, to be brought up to speed. And that's really the point of the blog, is that people can read my book and they can follow me and they can read my blog and they can easily get access to the latest code. They don't have to figure it out for themselves. Like I figured out the thing that needs to be updated. And so the blog is this living extension of the book
Hmm.
that allows people to keep revisiting and keep using, and find what I'm working on, find what I'm thinking about, um, because I couldn't fit everything into the book. Like I didn't want to write more than 400 pages. I wanted this to be an approachable book. I didn't want it to be a 2,000 page book, you know.
Yeah, not
But
intimidating.
but the blog allows me to just kind of be more of a mad scientist,
Yeah.
mad scientist. The blog allows me to be more of a mad scientist. Allows me to, like sometimes I'll get these crazy ideas and I'll want to just work on it the next day. And so to see if it's even possible. And, that idea isn't necessarily ready to be in the next edition of the book, but maybe it's a really good idea that should go into the next edition of the book, but it needs to be worked on first. And so the blog allows me a place to experiment,
Hmm.
and to write about what I'm seeing with this new approaches. And so since I've done my book, since I've done my blog, I have come up with some new approaches, and I have taken temporal graph analysis further. Well, it's not even in my book. I do zero temporal network analysis in the first edition of my book. So the blog is definitely an extension, and the stuff that's being written about on the blog will go into the second edition of the book. So
Right.
that's
I
how
think
it
that
goes.
makes sense. Yeah.
Yeah, it keeps it alive together. Yep.
Also, I think people can relate to it easily. Those who've been following your blog, they can relate to it. So the new content you add in the book will certainly help them resonate with what they've learned from the blog. So
Yeah, and the
yeah, I
shorter
think that
lessons too. Like
absolutely.
the book is like a 50-page chapter sometimes. And whereas a blog is like a 4-page tutorial kind of. You know,
Hmm.
it each one of those blog articles that I write, I sacrificed 4 hours of my Saturday to do it typically. So it takes a lot of work for me to do that kind of work. Um, but for a reader, it's a tutorial. Like it's basically start to finish. Here's a Jupyter notebook that you can replicate exactly what I did, and you can use this to jump in. So
Yeah, I think that also makes sense to stay connected with your audience, to push updates in the code or something of that sort. That really does help a lot of readers. Uh, David, you mentioned about system thinking sometime that you picked up on this term earlier and then you forgot about it. But now, since you've been actively working in this domain, and so how does it differ from traditional ways of understanding complex problems? And why is this approach so crucial in today's era where we have a lot of data driven insights and technologies coming up, especially say with large language models or complex networks, etc.?
okay, so yeah, this is an easy one. Think about Star Wars. Think about Luke Skywalker and all those guys attacking the Death Star. You remember that scene in the movie?
Yeah,
Um, they knew to attack this one spot in the Death Star, and the whole thing would blow up. Right? They had like 12 fighter jets or whatever. And so Luke Skywalker flies in, do all this blah 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 blah, and they get to the spot, and Luke Skywalker hits that thing with the torpedo, and the whole Death Star blows up. But imagine those 12 fighter pilots if they did not know about that one key weakness on the Death Star. Do you think 12 fighter pilots would stand a chance against that Death Star in the movie? Not a chance, nothing. They would not make even a dent, right? And
right,
systems thinking is like that. So systems thinking is also like the quote that I just gave. Um, Defenders think in lists, attackers think in graphs. Attackers are doing systems thinking. Attackers are mapping out your infrastructure. They are probing how things are working together. And when they do find their way into your platforms, they do more probing to see how things are connected as well. And
right,
so attackers think in systems thinking, and defenders need to also think in systems thinking. Otherwise, you are vulnerable. If you are only thinking in lists, you're just doing a top to bottom recursion, just going over and over and over. Check mark, check mark, check mark. Yes, this is good. Yes, this is good. In
mhm,
reality, a few of those things are way more important than everything else in the list. And so if you know that 3 of those nodes are more important than the other 97, you can really prioritize those 3 nodes. You understand? So systems thinking can be used for both offense and defense. You know, if the people who planned the Death Star had thought maybe it's a stupid idea to have one single point of failure, the Death Star wouldn't have gotten blown up in that movie. Like that. What a dumb engineering decision that was. So, but I know it's fiction. But reality is like that too. I've worked on production systems as well that have a few pieces of code that kind of serve as that kind of, it's a node where a lot of activity comes out of it. And so if that one node is disrupted, all of that activity falls apart, you know? And so systems thinking allows you to understand the graph as a larger object instead of an Excel spreadsheet, or instead of just a list of IP addresses or host names. Systems thinking is really how everything is connected together. Um, but it's the use cases of systems thinking. It's not just for cybersecurity; it's social also. Like if you want to understand anything about the world, you need to understand who's talking about the thing in the world. If you want to understand, if you wanted to dive into data science, you want to find out who the key influencers are, or you want to find
Right.
out who are maybe not necessarily influencers, but who are the key information subject matter experts in the domain of data science. Who are the people that are giving you information that is going to help you do your job. You know, before you jump into anything like data science or network science or any field, you should get a lay of the land a little bit. You should find out who are a few of the authors who, you know, and just do some discovery work. And again, that's the point of my book. Explore the networks around us.
Right.
Explore the networks around us using network science, social network analysis, and machine learning. So the
Machine
point of the
learning.
book is to help you think bigger, to give you systems thinking, to help you map out these things that are real things in your life. But it's not just about mapping out infrastructure. Like you can map out language as well. The day 35, I think on my blog, I do that. I show that language itself forms a graph. And if you look at the core of the graph, it's the common words like the and of and are and am and stuff like that. But if you look at the outskirts of the human language, it's words like
Hmm.
xylophone that are barely used. Like
Right.
you've probably used the word xylophone this year fewer times than you can count in your hand. It's a really rare word for most
Right.
people. So, yep.
That's a good answer, David. I think that really sheds light for people who are not so technically inclined about system thinking, and how it can benefit all of us basically to rewire our approach in terms of how we think. And like you mentioned, thinking in graphs and not checklists is a very important point, because a
Oh,
lot of times, yeah, we are focused on checklists and we kind of miss the point while trying to tick mark something, and becomes only a tick box activity.
and let
So
me say one more thing too is that when you take these approaches like I'm teaching, and when you first of all visualize the thing, oftentimes the thing that you want to understand is not nearly as big or intimidating as you thought it was. Often it's a very small thing, you know. And once you understand the shape of it, it's taken shape. It's no longer this mysterious thing that you think about. It's now a concrete graph. Like you know how it's working. Like you can actually see it, visually, and kind of understand the flows between the different nodes and how they interact with each other. So systems thinking isn't just it's not just a bigger way of thinking. It gives you peace. Like I use this to uplift the server, and the server we did before in 2015. I didn't have these approaches, and it took us 13 months to do. And after coming up with this approach, we were able to do things in 1/10 the time. But not only in 1/10 the time, the mental drain was
mhm.
massively dropped. So, I mean, it was probably 1/10 the mental drain too, because I didn't have to store the mental model of that whole server in my head or in a whole
Right.
bunch of text files. I actually had a living network, basically. So, yeah.
That's a very good point, like how you can basically think about storing stuff as well, so that you're
Hmm.
not really burdened with a lot of things that you need to do. Uh,
Hmm.
Typically, that happens if you follow a checklist approach, or have things, the to-do list kind of an approach, wherein you have a lot of things burdened one by one, and you keep ticking it off. So that's a very good thing that readers can really benefit from.
Hmm.
Uh, Now we can move to the next section of this podcast, which is around how the power of networks are exploring system thinking, because it's a very important topic and not a lot of people have talked about it in recent times. So my question on this topic to you is, many people may think that network science is purely academics, because like you mentioned, the books which were popular in network science were more inclined towards academia, compared to your book, which is highly practical.
Yeah.
But you emphasize it has practical applications. You've shown these applications in your book. So, how can readers apply system thinking in that everyday lives or professional work? I think you've covered it in the previous question a little bit, but if you can give examples of how,
Yeah.
people can try and use it.
So first of all, yeah, it's definitely not purely academic. Google exists because PageRank. PageRank is a part of network science. So
Right.
PageRank has to do with the number of incoming and inbound and outbound links, but it's nodes and edges. Um, so Google was an academic idea that was made practical, and it was so effective that we say Google it. So whereas the old approach to search engines, it was directories, it was lists, and so graph approaches have been changing the world practically for a really long time. But for somebody, if they want to get into this stuff, if they want to learn how to really capitalize on systems thinking, step one is to start thinking about it. Like just go outside and start. Just take a little tiny notebook. I've got little notebooks like this size all over my house, and I like little notebooks like that because they don't take a. You don't have to write a whole page. You can just use them for your little ideas. You can just come up with your little experiments and things like that. But you have to start thinking about systems. You have to start thinking about the systems that you exist in. You have to start thinking about the systems that you work with, you know? So if you work with a database, you should start thinking about what does that look like graphically. If you are a part of social networks. Everybody has friends and family.
Right.
You can draw a social network of that to understand your own friends and family better if you wanted to do that kind of thing, you know? So the hello world of network thinking or systems thinking is to jump in and start doing it and just try to shift your thinking beyond lists and start thinking about how things are connected. And maybe one exercise is to go outside and look up at the stars. And when you're looking outside of the stars, pretend each one of the dots is a database table or a file type or something like
Hmm.
that, and start
Yeah.
thinking about how they would be connected. Like this gets back into the imagination place. And imagination is the thing that's going to take you further. So it's time for everybody else to use their imagination to dive into systems thinking and network thinking. And the first thing that they need to do is if they are doing things with lists, acknowledge it. Acknowledge
Hmm.
your weaknesses, acknowledge places where you can uncover more complexity. If you have, for instance, a table and it has a person and a category,
Hmm.
you can create a social network off of that alone based on the people that like the same categories of things, using the approaches talked about in my blog, using bipartite projection, for instance. So um, you have to just jump in, and then you have to let your mind go a little bit further, and then let your mind go a little bit further. Like this is not traditional thinking. This is
Hmm.
different. This is higher level thinking. So you just have
Right.
to do it. Just jump in and start. And if people have ideas and they're curious, they can always reach out to me on LinkedIn.
Yeah.
Yep.
Absolutely. Yeah. David, yeah, your LinkedIn is a very good resource for anybody who is trying to learn new things, especially in data science and network thinking. And do check out David's blog, 100 Days of Network. So that is a great blog. A lot of readers are following that and they get a wealth of knowledge from it. David, you mentioned network thinking, and it plays a very central role in your work and what you do, and how you build companies, how you do research for top companies. But can you explain how this concept is helpful in understanding the how the real world is connected, how real world systems are connected to each other?
Yeah, I'll give an example of a data problem that I actually fixed once. And so this was a
Hmm.
multiple server problem. You know, um, let's just say server. Let's just say database A and server B. But the database would create an export, and this other server would use it for some data science stuff. And so this server was very important. It's doing important data science stuff that keeps all of us safe. And if this export doesn't happen, then it
Hmm.
can't do the thing that it needs to do. You know, um, a database administrator or a SQL developer isn't
Hmm.
necessarily thinking about that server. They're thinking about the database, and they're thinking about if their query works and if their query is correct and if it returns the right rows of data. They're not thinking about if the query works and the downstream export script worked and the file was created and the server got the file that it needed, and then the server created the output file from all of that. It's a whole supply chain that goes into things happening in production, you know, and it's complexity. It's not just one path. That database is working on 100 paths, 100 different exports for 100 different data science teams or
Right.
whatever, you know. And so databases are part of this complexity. And anyway, this one very important export failed one time. And going back a few years before that, there was another server that was a data science server and it crashed. And it took the whole team about a week to even figure out what that server did. So nobody even knew what that server was for. It was like a 15-year-old server, And
Mm.
so people had to go figure out what that server was. People had to figure out what was running on it. People had to figure out what files it kicked out. People had to start from discovery because none of the discovery work was ever done. In this database situation, I had done the discovery work because I
Mm.
had actually designed, I was part of designing that database. And so I
Right.
had done a lot of this graphing it out, understanding how the exports worked. So, but a couple of years after I helped build it, the DBA reached out to me and said, "This export's not working. Do you know why?" And I said, "Hang out with me for a minute."
Mm.
And so he hung out for me for a minute and I pulled up the graph of how the database actually works and could see the export and could see the one thing that was right before it. And so we solved that problem in a couple minutes versus the previous problem that took over a week because
To
they had been
solve,
stuck
yeah.
in discovery. So if people want to solve problems, graph it out ahead of time. Not be, and if you do go solve a problem, please graph it out so that the next person that has to solve the problem has a map to work with at least, you know because a lot of these approaches that I came up with are because nobody gave me a map because there was no map. So I had to come up with approaches for mapping.
Right. I
So
think,
that's the
yeah.
real world. This has real world use for data
Use.
operations, for solving problems, for social issues, for understanding literature, like to actually get to know how authors work. Like
Hmm.
you can analyze the complexity of a social network in books. You can say that Lewis Carroll, um, Alice in Wonderland has a much more complex social structure than the Metamorphosis by Franz Kafka. You know, it shows that in my book. And so the two writers, they might be stylistically complex, but they're thinking about the characters and the stories different too. So it opens up some really interesting doors for computational humanities and everything.
Right, right. I think that's a great example that you shared from your real world experience. Running data operations at such a large scale, this can really help companies, organizations who are doing it right now to map data out, to map the architecture out in a way that it is easily identifiable if something goes wrong, compared to the traditional conventional approach where it takes weeks to figure out that what went wrong and why is it not working as designed. So I think that's a really important point, and thanks for sharing that. If I move ahead to something which is related to this, so in your book you introduced the idea of exploring reality through network graphs. So if you could shed more light about how this can help in taking better decision making in complex situations, like you gave the example in your previous answer, where you were running these very complex, very large scale data operations. So if we were to use some similar examples, how would you say about it?
I would say that people shouldn't think too much into it. They should just try to find somewhere to start because it's really most important is just start. Like don't come
Hmm.
up with a whole bunch of prerequisites. Don't come up with a whole bunch of I need this. I need a graph database. I need blah 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 blah. Because that gets to the point of why I wrote this book was to teach people the fundamentals. And so the first thing that you should do is really just find a place to start. Find something that you're interested in solving or making better. Or understanding better. So it doesn't matter if you work in biology or if you work in computer science or if you work in humanities or if you work in the social sciences, you work with graph data and you work with networks of some sort. And you can use these to get a better awareness and understanding of the thing that you're working on. And so if you're a data operations person, think about mapping out the server that's giving your team the most headaches. Seriously, that will make your data people love you, um, because your problems are going to get shortened. Like I said,
Hmm.
1/10 or more. You know,
More, yeah.
um, yeah, it's probably even more, um, because a week versus an hour in terms of that database issue. You know, so but it wasn't just that database issue. We use this to troubleshoot other things. And we also use this to reverse engineer things and then
Hmm.
rebuild them on more modern architecture. So if you're
Right.
going to do any kind of re-engineering work where you want to replace this 10-year-old old and dusty thing with
Legacy
some new
systems.
approach, you need to map out the data flows. You need to figure out how the thing works. And if you don't, then I bet you just have text files where somebody's just written about how they think it works. Like there's a
Hmm.
difference between thinking you know how it works and knowing how it works. If you have a graph and you've actually mapped out A produces B, you have an edge. And if you do that for everything that runs on that server, you have the actual graph of how the thing works. It's not, I think I know how this works. It's not, I think this spreadsheet is still accurate. I don't like any of that vagueness. And me as a data operations person, I fought against that kind of stuff. If you gave me a 10-year-old spreadsheet, I'm starting from the beginning. I'm going to look at cron jobs. I'm going to look at orchestration, and I'm going to
Right.
map out the whole server because you gave me a 10-year-old spreadsheet. So the way for people to start is just find the one thing that's causing annoyance or curiosity and start by figuring out how to graph it out, like figuring out how to map it out. If there's relationships involved in it at all, like a database has related tables. If there are things that are related, then it's a graph problem. You know, if you wanted to map out podcasts, it's people to people. You know, you can do that with
Hmm.
graph as well. So the point is, don't overthink it. Just start. Find something simple. And if your first idea feels too complicated, find something simpler, or map out only part of it. Like just go slow. Go slow before you go fast.
Right. I think taking that first step is very important.
Yep.
Starting off, getting up the ground is very important to take your first step. So I think great advice there, David. Final
and it gets
question about,
and
yeah.
it gets easy. Sorry, sorry to interrupt you. And I want to say this sounds complicated because we're talking about wrangling complexity. This stuff does become stupid easy for
Right.
analysis. Like this stuff, I do it late at night for fun.
Yeah.
You know.
It's become muscle memory to you, David. So I think
Mhm.
that is why you enjoyed a lot. I think, yeah, I mean, once people get started, they will start enjoying it, because once you get it engrossed in your thinking, that is when you start having fun with it, is what my view is about it. Uh,
That's right.
yeah, one final question around this topic, David. So what, you've given a lot of advice to a lot of viewers, but somebody who's, just starting off from a point zero, what would be your advice if they want to start off in system thinking or network thinking? How can they see the world or see their professional work through this lens?
Mind map, mind mapping. So mind mapping is the easiest way. There's a lot of tools for programmatically creating mind maps and stuff like that, but
Hmm.
I'm really against that. A mind map should be as easy as drawing on a whiteboard,
Hmm.
because if you have if it takes 3 steps to draw a mind map, you're not doing a mind map. You're doing a programming project. So mind mapping is about as natural of a way to start thinking about systems thinking, because you start with a dot and then you start thinking about what else is connected to that dot, you know, and you're doing it based on your mind map that you already have in your mind. It's just you're untangling it for yourself and you're drawing it on paper, or on an app or something like that. But once you're done, and it takes work to do anything with a graph.
Right.
But the fruit is when the graph is done, you have a visual thing that you can analyze. It's an organism almost. And a mind map is like that too. Like if you're if you're struggling with finding a job, or if you're struggling with um, starting your career in data science, you can mind map the things that you think are getting in your way, or you can mind map the flow of landing where you want to land. And so um, part of this is just drawing this complex bubble of, this is a mind map of all of the knowledge related to this one thing. Like data science is related to machine learning and artificial intelligence and network science and blah blah blah, you know. But other mind maps can also be a flow. Like you're starting here. This is where I am in my life, and I want to become a data scientist. This is where I want to get to. So what do I think is the step B, and what do I think is the step C after that, and what do I think is the step D after that? And you might not know what comes after step C. Don't bother with after step C. Get the step C. Like make progress in your life. Take little tiny baby steps, and eventually you're going to be in new territory. And from there, you can figure out steps D, E, and F.
Great advice, David. I think that will certainly help a lot of people who are starting from zero to take that first step and start using network thinking and system thinking in their daily lives. Start looking through that lens. So, on that note, moving into the third section for the podcast, like you mentioned, three parts is where people understand things the best. So, yeah, so the third section is more to do with where we get our hands dirty, a lot of applications, a lot of practical stuff. So how does your network science with Python book provide a unique entry point? Because a lot of beginners are listening to this podcast and they want to start analyzing complex networks. What would be your recommendation to start off with in your book particularly?
So the reason why I wrote my book the way that I did, like I wrote it with fundamentals. And so the thing to really do is just to read my book, because it's already written in a step-by-step way for
Man,
beginners
yeah.
to go from nothing to where they need to be. Um, but really, you have to learn the very basics of data science in order to read my book. And by that, though, I don't mean more difficult than learning pandas. Like you at least should be comfortable creating a pandas data frame, um, if you want to create an edge list so that you can create a graph. Like that's the 1 2 3, is you have to have an edge list in order to create a graph. And so I use pandas to create that edge list. You don't have to use pandas to create that edge list, but I do.
Hmm.
I just find it easiest to do it that way. But pandas is nothing to be afraid of, and there are many books that have already been written on the subject. And you don't even, I don't want to say you don't need a whole book to read pandas, because I don't want to kick dirt on my friends. Their books are great. You should read their books because they'll teach you
Right.
how to go far in pandas. But to create an edge list in pandas, you don't need to read a book to create an edge list in pandas. It's literally pd dot data frame and pass in the source and the target. It's very simple to do that, and then pass that to network X. So to go from nothing to graph is very quick. But the way to get started is to just read my book, and um, do read those books on pandas. Do read those books on data science. Like when I dove into data science, I bought 7 books, like immediately. Like the day that I made my conscious decision that I was going to jump into this field from data operations, I bought seven
Hmm.
books that day. I spent $300 on books that day, and I knew that a couple of them would probably be mediocre, and a couple of them would be great, and the rest of them would be average. But that's how you dive into an ecosystem. You pick up
Right.
multiple sources of knowledge, and you find the good ones, and you keep them close to you, and you find the ones that are okay, and you put them away, and you'll use them more later on. But you have to find the source that's going to kind of guide you at first, and then as you build muscle memory and skill, the training wheels come off. Like if
Hmm.
you play with my blog and my book for a few weeks, you don't you're going to be doing your own thing. You're not going to need me for training wheels.
Right. That's a good point. David, you have an ability to make complex concepts very accessible and engaging. That is, I think, one of your very strong points. The choice of examples you take in your book or your blog is also very relatable. So, what would be in your view, suggestions for projects if somebody wants to start applying network science? I think you mentioned one, which is about creating your own social network, the people you interact with most. But any other projects that you think people who are starting off to apply network science should pick up first?
Yeah, everybody has a favorite song, I think. So, like read my blog. I would say probably play with some of the computational humanities stuff. Play with the fun stuff. Don't play with the serious stuff. Don't play with the stuff that looks smart. Play with the stuff
Hmm.
that looks simple. You know, um, don't shy away from smart. Don't shy away from complex. But you don't have to start with it. Like when I go swimming, the pool is always cold. So I put my foot in first. I'm not just some crazy person that just jumps in, you know. And and no offense to those that are, they're braver than me, but I can't do that. Like I put my pinky toe in, then I put my finger in. Like this water is too cold. And data science is the same way. And I was the same way with data science. Like first you learn pandas, then you learn matplotlib, then you learn probably graph is a good thing to learn after matplotlib a little bit. Like you should probably play with graphs before you play with machine learning because graphs are a little bit simpler than machine learning. And they are visual and you can see them and you can use the graph data with machine learning, as I talk about in the last two chapters of my book. So um, for simple things to start with, I say start with things that are fun for you. And I don't know why I picked the book of Genesis for my first one. I like to do things that seem impossible. I don't like to start small. So I typically break my own advice, that I'm giving right now. I'm like, let's try to build a rocket. That's more of my personality. But so I started with the book of Genesis, and
Hmm.
that was a slam dunk first attempt. But if
Mhm.
people aren't that courageous, start with a song. Pick your favorite song and do the word graph like I show how to do on day 35 or whatever I do on my blog. You know,
Right.
and part of the maybe it wasn't day 35 when I did the song one, but in the song one I also showed even a chord graph. Nobody talks about chord graphs in
Yeah.
network science. That was a thing that I just did because I play guitar.
Yeah.
I wanted to see what the chord graph looked like. And so a song has multiple things going on. A song has the lyrics to it, but it also has the chord progression to it as well. And it also has the lead to it too. So there's a lot of information tucked away inside music, and you can do things with music like cosine similarity between
Hmm.
songs to see what other songs are similar, and you can do things with similarity even with graphs, with chords to see which other musicians are similar in, musically. So there's just so much that you can do with graphs that you don't have to start with work. You can start with fun, and that's really how my mind works. Is I don't figure stuff out for work first. I figure stuff out for fun first, and then I think about what are the very serious things I can use this for, and then I go build them. So
Right.
that's what I recommend. Find a way to have fun with it, and then the learning is natural.
Great, great tips, David. I think that will really help people who are starting up to finally take that step forward and start building stuff. So, David, I think people who've bought your book and are subscribed to your blog, they kind of have a good chunk of David with them. So, what are the type of conversations or interactions do you look forward to on LinkedIn? Because you have a very big network of people who are connected with you, and there are a lot of people reaching out to you a lot. So, any thoughts on those? Like, I know you are very approachable, but anything that you look forward to when you expect people to reach out to you?
Yeah, people do reach out to people. I got a message today by a friend of mine. Like everybody who talk graphs with on LinkedIn, I sort of become friends with. So
Right.
they get
Right.
obsessed with it, and then we just start going back and forth. You know, but one messaged me today saying that they were doing some network science and something that they were working on too. So I get really excited when people tell me, what they're working on, or asking me if they think one of their ideas is applicable for graph. And it typically is. Like typically, they'll have a hint that this will work with graph. Like they feel it, but they just
Hmm.
want to reach out to me just to save them some time. Um, so do reach out to me if you have any ideas. like, this is something I'm dealing with at work. Do you think this will work? Do you think that what do you think I can get out of this? Feel free to ask me those kinds of questions. And if you get stuck, like, my book is a couple years old, so if you do get stuck on any part that I don't know about, reach out to me. I want my book to be a resource. I didn't write it to make money, you know.
Absolutely.
I wanted it to be a resource forever. And the thing that I love about network science compared to machine learning or AI, network science isn't changing every single day. There's not a new model that you have to go learn every day. If you learn network science, you're going to learn about community detection. That's going to be relevant in 1,000 years from now. If you learn
Right.
network analysis, you're going to learn about egocentric network analysis. That's going to be applicable 1,000 years from now, and it was applicable 1,000 years ago. So all of the stuff that I'm teaching in my book, it has a longer lifespan than some of these other topics that are being talked about. And so it was very important for me to just write the book. And there are code things that are going to need to be updated so that the code works, moving forward, because Python libraries evolve, and not just
Update.
network
Yeah.
X, but the libraries that are underlying network X, you know. So the book has to have a life of its own. And I know we want to talk about when the second edition is going to come out and stuff like that. So I am very excited to write a second edition. I just have to find time to do it. But I'm getting that itch, like I have to do it. Like, I can feel it, that it's about time for me to get started on it. And there's only a couple more chapters that I really want to include, because, like I said, network science as a field, for a foundational book, that book will always be the foundation. It's just that I might want to add a few more things to it. And so the next iteration of the book, I want to add more to it for temporal network analysis, because I wasn't really confident enough to include that in the first edition. And because I
Hmm.
wanted to do some experiments, and I came up with some wicked cool stuff on my blog that I definitely want to include in it, because I can, for instance, identify what has fallen out of the network and actually redraw it. Like, that's a really cool thing, being able to see what is no longer present in the graph, and you have to have the before to show the after. So temporal network analysis will be in the second edition, and some other cool stuff that I'm kind of cooking up, but I'm not sure on yet. But it's coming.
That's great to know, David. I think because there was a question that will we get GTA 6 before David's second edition? And I think, yeah, we are on the right path and we will know soon what comes
Yeah,
first. So,
that it won't be that long, and I don't think that it will take all that much time to write, because
right,
we'll go through and edit the old chapters. We'll go modernize the code. Maybe we'll take some new screenshots or something. But the spirit of those old chapters remains. They're good,
right.
and we will add a few more chapters, and that takes it takes a lot less time to write 2 chapters than it takes to write an entire book. Period.
Absolutely.
So,
Absolutely. That makes sense because you've done the groundwork. Now you want to build on top of it. So your book is quite relevant. It is based on fundamental topics. So they stay relevant for a very long time. So now you're going to build on top of it with advanced examples and, like you mentioned, about a temporal. So I think that will be very interesting to see. And there is a lot of interest around that. Moving ahead, final question for you, David, is so there are a lot of researchers and professionals, especially in today's time where there is a lot of emphasis on AI, large language models, generative AI, I think, but all the fundamentals remain the same, which is network science and AI and how to think, network thinking and system
mhm.
thinking. So, what do you think the skills and knowledge one should focus on to stay ahead of the curve in such a time where AI is rapidly, improving and we are seeing a lot of new stuff coming out?
Yeah, my favorite thing about um, systems thinking and network science is that it allows me to really focus my attention on the things that I need to focus on, not the whole thing at once. And so, what people do without systems thinking is they try to understand everything all at once, And I like the title of that one movie, "Everything, Everywhere, All at Once."
Yeah.
But that's kind of what AI feels like today. There's
Hmm.
a million arcs of articles coming out. There's information coming from everywhere. There's influencers talking nonstop, and so it's just hammering of noise, just bam, 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 bam. You
Yeah.
know, but when you think about systems thinking, or as part of 100 Days of Networks, I created an arxiv crawler, for instance, and so in doing the arcs of crawling, I was able to map out artificial intelligence by authors. These are the authors that are talking about this. And
Hmm.
so I created a data set of artificial intelligence. I created a graph with that, and I could analyze each of the sub communities in the ecosystem separately. And so that's a very cool thing to be able to do, because part of artificial intelligence is artificial life. That's a fascinating field of its own. People should go study that too, you know. And part of artificial intelligence is machine learning algorithms. That's a really cool thing to do too, if you're very mathematical and have an engineering mindset too. But if you don't have that, you might be more interested in that, like there are different parts, there are different pockets of AI and machine learning and intelligence to understand, and not all of it needs to be understood all at once. And it's not
Hmm.
always the most popular paper that needs to be researched. Like this is one of the network science problems of the world, is that because of things like PageRank, things that are popular get bubbled to the surface.
Right.
But often the most informational things are not the most popular things. And so this is the strength and the weakness of network science, is that network science can show me that this is the most popular thing, but I can also see the isolate nodes that nobody is linking to. And those
Hmm.
isolates are sometimes rich. Like those isolates, or some of the barely connected parts of the network, are where some of the most interesting research is actually happening,
Hmm.
the most
Right.
creative type stuff, you know.
The
So
most value additions
yeah,
come from those.
so
Yeah.
so you can apply systems thinking in your own artificial intelligence research by using my arcs of crawler that I made available in 100 days of networks.
Right.
And
Yeah.
crawl arxiv, no matter your topic of interest, it could be biology, it could be artificial intelligence, it could be something from the social sciences. Do the community detection to see what the pockets are that are talking about it differently, and then find the pocket that you belong to and study from
Hmm.
that. Because I will tell you, everybody always complains that they feel overwhelmed all the time. I do not have this problem at all, and I have never had this problem at all. Like I
Right.
prioritize my learning on the thing that I want to learn about, and I don't feel that I have to learn everything. So it's really, it's about, it's systems thinking with information, and knowing my pocket. Like this is the pocket of information that I want. And all of this stuff over here, I can just disregard it for now, and I can come back to it later.
Right.
It still exists, but I don't need to be in that ecosystem.
Only stay focused on the things that you are interested in, and rest is
Yep.
noise, and you don't really pay attention. I
Yep.
think
And so
that's a very good point. Yeah.
focus is the good word, and it's very easy for us to say, stay focused, stay focused, stay focused.
Hmm.
But it's one thing to say stay focused, but like this is an actual approach to stay focused. Like you can actually use this to have
Yeah.
laser focus on your one subject matter that you're interested in.
Absolutely. That is a very solid advice, David. I think I have reached towards the end of my questions for you today. Like always, this has been an incredible discussion, David. I really appreciate you taking time out for the podcast and sharing your knowledge with the viewers, with the readers, always giving back to the community. This is really something that is close to my heart. And I think you've been doing a phenomenal job in educating a lot of people who are new to the field and providing them a lot of free resources, and then your book, and then contributing to your book and updating it while you have a very busy schedule. So thanks a lot for doing all of that, David, for the community. And it's always been a pleasure talking to you. If you have any final closing notes, so we'd like to hear that.
Sure, man. And I really want to thank you and Ravit from back in the day,
Right.
and Pact. Like you guys gave me the opportunity to share what I've learned with the world, and previous to this book, I did share this information at Intel, and I did share this information at McAfee. But at work, people have other problems that they're solving.
Right.
If you don't write a book, the knowledge just eventually falls off. Like people are busy
Disappears.
solving
Yeah.
problems. So
Hmm.
I really want to thank Pact, and I really want to thank you, and I really want to thank Ravit, who introduced me, um, for allowing me to do this. And I love the LinkedIn community, and I'm always happy to share information with them. And I love all of our conversations that we've had over the years, because I've talked about cybersecurity, and I've talked about artificial intelligence, and I've talked about data operations, and I've talked about just everything. But my following sticks with me. I'm, I'm,
Right.
I'm not I'm not a one topic voice. just all over the place. So thanks to everybody who's watching this podcast. Thanks to you for having me on it. I'm excited to talk with you more, Ali. I have other ideas for books that we can talk about. I have an idea for
Right.
a non-programming book that maybe we can write on use cases or something like that.
Absolutely.
So exciting times, man. I'm always happy to be here. And thanks for having me. This is a great day.
Thanks a lot, David, for your time. And I hope you have a great day ahead. Thanks a lot.
All
Bye
right.
bye.
You too. See you later. Bye.
So that's a wrap, folks, for today's episode of All About AI with Ali Abdi. I hope you found our conversation with David Knickerbocker as fascinating as I did. We explored a lot of cutting edge advancements in network science, AI, machine learning, and David walked you through some valuable insights and his personal experience that he's gathered with time. I hope you enjoyed this episode, and please consider subscribing and click on the bell icon to never miss on any updates from us. We put in a lot of efforts to get these experts on board for you guys, and a like and a follow will help us a lot. So stay tuned for upcoming episodes where we try to bring you the best in machine learning AI that the field has, and we try to get a lot of insights from these experts. Until next time, take care and always stay curious. Bye bye.